Okay, this lesson's on how to solve trig equations, but equations that are in quadratic form, okay? So any equation that has a squared in it would be in quadratic form, okay? And in doing so, the old rules of quadratics, how do you solve a quadratic, come in play, where you need to either factor or possibly use a quadratic formula to get the x by itself. Now, one thing that some people might want to do is just to make a quick little change where you let, say, sine x equal just a plain old x. So that if you had a sine squared x, that could be replaced with an x squared. That's just a little trick some people do to make it look a little more familiar, but that's only a temporary little change. So let's take the first example here. 2 sine squared x equals 1. Now this is a quadratic, so let's make it equal to 0. 2 sine squared x subtract 1 equals 0. Okay, quadratic is equal to 0. Now, I don't like the way that looks. Let's replace the sine x with just an x. So I'm going to let sine x equal just an x. And that's what's going to be temporary. So it's going to be actually rewritten as 2, and that's sine squared x, so 2x squared minus 1 equals 0. Now, if I factor this, this is difference of squares. So I'm going to have the square root of 2x plus 1, square root of 2x minus 1 equals 0. And if I want to get x by itself, or I want to solve these two brackets, I make them equal to 0. So I have the square root of 2x equals negative 1, x equals negative 1 over square root of 2, and same here, square root of 2x minus 1 equals 0, square root of 2x equals positive 1, x equals 1 over root 2. But it's not really x equaling 1 over root 2, it is actually sine x equaling these values. I only temporarily made that change, so I do need to change it back. So when does x equal these values? Negative 1 over root 2 or 1 over root 2? Well, the 1 over root 2 comes from the triangle with the 45 degrees in it. 2, 1, square root of 2, 1 and 1. Okay, and so it's 45 degrees, and I have both the negatives and the positives, so meaning on the cast rule, all four quadrants have negative and positive. The positive ones are going to be here, 45 degrees and 135 degrees. But it's also going to be down in the two other quadrants for the negative one. 225 degrees, 315 degrees. Now what are those as radians? Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that is my answer. X equals, and I have pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and my domain is not specified, so I need to do plus 2k pi. There might be other possible answers as well. It depends on if the cycle continues. Here's another quadratic. Sine squared x plus sine x minus 2 equals 0. Now I don't like the way it looks. It is equal to 0 at least, so that's a good thing to start for a quadratic. But let's let sine x equal just simply an x. So that means I'm going to have x squared plus x minus 2 equals 0. Now to solve this, I can use a quadratic formula, or I can factor. Is there anything that multiplies to negative 2 and adds to 1? That adds to 1 and multiplies to negative 2, so that would be 2 and negative 1. So I want to have x plus 2x minus 1 equaling 0. That would equal x equals negative 2 and x equals positive 1. But that's not really x, those are sine x equals negative 2, sine x equals positive 1. Now we know that sine, the sine function, only goes as high as 1 and down to negative 1. So 1's okay, but negative 2, it will never get there. So this is not possible. So sine x equal 1 is my only answer. And what does that mean? When does sine x equal 1? Well, it equals 1 at 90 degrees. So therefore, x must equal pi over 2. Domain is not specified, so I would do plus 2k pi. If my domain is specified, I put it in different k values and figure out other possibilities. Another example here, I have 2 cos squared x equals cos x plus 1, and I have my interval here where it's a defined interval. So let's make it equal to 0. 2 cos squared x minus cos x minus 1 equals 0. I don't like the way it looks, so let's let cos x equal just x. So I have 2 x squared minus x minus 1 equals 0. Now I could factor this, but for practice sake, let's use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Put your values in. Negative 1, negative, I'm having a hard time here, negative 1 plus or minus square root negative 1 squared minus 4, 2, negative 1 all over 2 times 2. So that's going to give me 1 plus or minus square root of 1 plus 8 all over 4. 1 plus or minus square root of 9 over 4. That's a perfect square, which means I could have factored it. Anytime you have a perfect square in quadratic formula, the square root it means you could have factored. So I have x equals 1 plus 3 divided by 4, and x equals 1 minus 3 divided by 4. So x would equal 1 in that case, and x would equal negative 1/2. So that's not really x. If you remember, we let cos x equal x, so it's actually just cos x. Got to replace it. So when does cos x equal 1? Well, that equals 1. Think of the unit circle. Cos is your x values. So that equals x equals 1 at 0 and at 2 pi. When does cos x equal negative 1/2? Well, negative 1/2 comes from the 60-degree triangle. 60, 30, 1, 2, square root of 3. 1/2 is 60 degrees. But because of the cast rule, it is in these two quadrants right here, which is 120 degrees and 240 degrees. That's 2 pi over 3, and that is 4 pi over 3. So put those in. Pi over 3. Now I do have to do plus k 2 pi. I do need to check. I have an interval from 0 to 3 pi, so I need to add on 2 pi's until I get above 3 pi, which I have a denominator here. I had a denominator of 3, so 3 pi is secretly 9 pi over 3, and that kind of gives me how far I need to go. So let's start adding on 2 pi's. 0 plus 2 pi is going to give me 2 pi. I already have that one covered. 2 pi over 3 plus 2 pi. Okay, so denominator 3, so that's plus 6 pi. That would give me 8 pi over 3. Hey, that's below my 9 pi over 3. And if I go any further, add on another 2 pi into this one, I'll be out of my range. So I actually had just the one additional angle to add on. Okay. Remember, you're working with fractions. If you're adding 2 pi, it's because the denominator is 3, it's actually 6 pi over 3 that you're adding on. So that's right, I did the 2 pi. Add the 6 pi gives me 8 pi over 3, which was below the 9 pi over 3, my 3 pi, so I knew I was within my range. This is a short lesson on solving trig equations that are in quadratic form, and you can do factor or the quadratic formula to do so. Thank you very much.